The intention of this session is to explain 4 stages of competence model in SACE subjects learning, in particular mathematics. Then we use CT2, RC3 and 4 as examples to show you how we become consciously competent and eventually to be unconsciously competent. After this session, you should be able to use performance standards to respond to questions purposefully, which is consciously competent. Then, form a habit in line with the performance standards over a period of practice, which is unconsciously competent. Therefore, during a test, you will be able to lighten your mental load and just work on the question. We will firstly explore the 4 stages of competence model and how it applies to learning in SACE subjects. Next, we will delve into 3 pieces of performance standards, guiding you through an analysis of case 1, 2, and 3. In these cases, all solutions are correct, which is traditionally believed to be an I, but not all align with the A band of the standards. Finally, to wrap up this session, we will focus on relevant study tips to enhance your learning outcomes. Young children often exhibit a high level of confidence, aspiring to become scientists, lawyers, or maybe singers. This confidence usually stems from a lack of awareness about the skills and knowledge required for these professions. Similarly, I encounter students who correctly solve a question and assume it is an I. This assumption might arise from a lack of understanding of what an I-grade response likes. This phase is known as unconscious incompetence. I've observed that some students in senior subjects, such as physics and spec maths, display less confidence. I say it positively because there is a progression to the second stage of learning. I'm confident that if you are watching this video, you are motivated to improve. With this motivation, you can certainly advance to the next 2 stages of learning. Conscious competence stage is where you have known the expectations. Then, you are planning your writing response. You are evaluating your work. You are synthesizing concepts and techniques from multiple topics. You are purposefully doing this higher order thinking work in order to reach the A-band criteria. In the final stage, you have fully understood the standards and have developed a habit in your response writing. This allows you to produce work at A-band under test environment. The last 2 stages of competence model involves engaging in higher order thinking. This is because you actively analyze your work against the performance standards. You select knowledge and techniques from a variety of sources, and you critically evaluate your own work. This type of thinking skill underpins metacognitive learning because it involves a process where you initially brainstorm and visualize all possible responses when solving problems. You then carefully select and plan your response to meet A-band criteria. You also monitor and evaluate your thinking and writing actively throughout this process. These are the 3 pieces of criteria selected from the performance standards and will be the focus today. In one formal assessment, like a SAT or an investigation, not all criteria are used to assess your work. It is important you fully understand the descriptor. You may seek clarification from your teacher if you need. One way to check your understanding is that you mark your own work in line with the standards. And if the grade you give to yourself is consistent with your teacher's, this means you understand the expectation. Let's look at today's first example, case 1, binomial expansion. You may be at least year 10I or year 11 methods. Here is the first solution. The power is firstly expanded, and then the method for you learned from middle school is used. And it has been used 4 times and then created a very long response in solving this problem. And the thinking is very easy. However, the calculation is hard. For this work, I would give a C for CT2 because the technique is not highly effective. It does give you a correct answer, but it is not senior concept and technique. If we look at RC3, the notation and representation are generally good, and there isn't much chance of showing terminology. Designing a test which gives students the opportunity to demonstrate their ability can be challenging for a teacher. But as a student, you can purposefully show off your abilities, like deliberately using higher level of notation and representation. For RC4, the writer's strategy in solving this problem is very clear, easy to follow, and quite logic. However, it is super long and redundant. This is largely because of the selection of technique, CT2. This illustrates how criteria within the performance standards can impact each other. For solution 2, the writer split the power first, then use the formula of the square and the cube of binomial. After that, there is a for you. So you can see that it is visually shorter and it shows off more techniques. So compared to the first one, it has more thought and less calculation. So for the second solution, there is improvement in the method selection, but the RC3 and 4 remain the same. In solution 3, the writer uses binomial theorem. This is what you do on your scratch paper. I put it here so you know how the writer gets this coefficient here and here, and also gets the correct answer. For this response, it uses effective technique and algorithm. In addition, higher level of notation is used, like here, leading to more effective communication. Let's look at case 2, index law. You may be year 9 and above. For this solution, it is very concise. However, it doesn't show much the writer's thinking and the selection of techniques. I can say calculator is used, and in this case, the technology is not used effectively because the answer is not accurate. It has been rounded off 2 times. I cannot comment on RC3 and 4 from this response. For solution 2, index law is used, and this technique leads to an accurate answer. The writer has also purposefully used higher level of notation, such as turning the square root of 6 to the 6 to the power of 0.5. The manipulation of notation and representation shows the writer's thinking. So for readers, the work is easy to follow. For example, here we can easily understand why how we get 6 to the power of 2, because the power cancelled, so 2.5 minus 0.5 is 2, so there is another index law, so make it to be 6 to the power of 2, and you get precise answer. The final case is integration. You may be Year 12 Methods students or Year 12 Specialist Math students. In the first solution, the writer fully expands the expression from here. Then integrate the 3 terms separately. That one, this one, and this one. For solution 2, the integration technique substitution is used, and the writer gets an equivalent answer to solution 1. Now, let's compare the 2 solutions. Solution 1 is in yellow box, and the grade is highlighted in yellow in the performance standards, while the solution 2 is in green. Both responses are correct, clear, logic, and easy to understand. However, the green one employs a more sophisticated technique to solve the problem, resulting in a more concise writing. In addition, the writer has used Leibniz notation, which is introduced in high school and will be an important concept in university-level calculus. So I would say it's proficient and accurate use of notation. Here are the study tips for CT2. As for day-to-day learning and practice, you will spend more time than usual in doing your homework, because you are doing reflective thinking and monitoring your thinking and raising your awareness by performance standards. You also seek feedback from your teacher and try to improve based on the feedback. And here are the 3 activities you do. Under a test condition, you spend roughly 10% of the time to brainstorm and plan, 80% of the time in calculating and writing. You also need 10% of the time in checking your work. So here are the study tips for RC 3 and 4. Again, in your day-to-day practice, you will spend more time to think, to evaluate your responses. And you ask yourself if your writing, your response is clear, logic, and if another student can understand can follow your strategy, can point out your technique and your mathematical thinking. Teachers usually can, but you can use your friend to test whether or not your writing is clear. Consider if there are better ways to represent your solution, and if higher level of notation can be used, which can make your communication more effective and concise. You ask for feedback from your teacher to understand your current performance band and how to progress, how to improve to getting an A band. Many of my students are only interested in which band they get. So, and B and C doesn't tell you where you are according to the performance standards. You need to at least to say the highlighted performance standards so you can improve, given that you can understand the performance standards. Under the test condition, our aim is to unconsciously respond to all the questions in a way which is aligned to with the A band of the performance standards. So to achieve this, you will form the habit from your daily practice. Thank you for watching. This is my second video, and I will make more videos to provide localized instruction for students living in South Australia. Subscribe if you like. You can also ask questions or let me know which topics you would like me to discuss.